as if somewhat similar to an impact. And in fact, when a rocket lands, it can generate a temporary atmosphere from the rocket exhaust. During the Apollo landings, it was estimated that the entire mass of the lunar atmosphere increased by 30% just from the rocket exhaust of the landing spacecraft. Now I want to say a few words about dust. Dust is a colloquial term that's used by engineers to refer to the very small particles in the regolith. If you remember, the regolith has particles of all sizes, from boulders to microns, but the engineers are particularly concerned about the small particles and how mobile they might be and interfere with equipment or operations on the surface of the moon. On Earth, dust can be mobilized and carried into the air, so we're familiar with dust storms or a dusty atmosphere, and we know that in mines, dust can get into workers' lungs. The moon really has no sensible atmosphere or any wind, and any particles that are moved from the surface or dislodged from the surface travel in ballistic trajectories. The Apollo designers really had no operational experience on the lunar surface and did not make special efforts on the mitigation of the effects of small particles, beside just good engineering practice. There were no failures due to the dust on the lunar surface, but some evidence suggests that problems might have arisen if the operations were longer or if we were on the moon for longer periods of time where the exposure to dust was higher. Some engineers who were designing lunar equipment in modern times became concerned that the dust or the small particles on the lunar surface can be mobilized by the surface electric fields. That concern was triggered by various observations and anecdotal evidence that indicated some possible movement of dust, but there's really been no confirmed evidence that it's a major problem. We've had operational successes on dusty environments on Earth or on Mars, and they support the idea that good engineering practice and appropriate operations protocols can prevent failures from the presence of fine particles on the moon. The Apollo 17 astronauts in orbit made some observations of reflected light on the horizon at very high altitudes, which has been interpreted as a population of very small particles streaming from the moon, which supports the idea of electric fields being a problem. However, examinations by spacecraft orbiting the moon since that time have dismissed this as a serious problem. Everyone is familiar with the idea that the lunar gravity is 1/6 that of the Earth. However, low gravity is a design environment for engineers for which we have limited experience. The videos of astronauts moving on the surface show them loping as opposed to walking. That particular kind of movement might be the most efficient way to move on the surface. If that's so, and you're inside a habitat, how high should the ceilings be so that you don't bump your head? Well, it should be the separation on stairs and staircases. And if you're designing things like distillation columns, which require gas to move through liquids, we don't know anything about how bubbles move in fluids in low gravity, although we can make theoretical calculations. So there's a number of practical considerations of operating on the moon that are hard to predict ahead of time, but we will learn through operational experience. The lunar gravitational field itself is